We are going to solve project order problem 31. The question is how many different ways can £2 be made using any number of coins. Of course we only have a limited set of coin values we can use. We have values of 1, 2, 5, 10, 20, 50, 100 and 200, and we need to get to 200, which is £2. So we're going to solve this using backtracking. First of all, I'm going to define the coin values, which is a list of integers. So we have coins of value 1, 2, 5, 10, 20, 50, 100 and 200. Now, how are we going to implement this using backtracking? The basic idea is that we take coins one after another, keep track of the sum of the coins that we've currently taken, and take coins until we reach the final value, which is 200. So let's do this real quick. I'm going to define the function number partitions, which will take an integer and return an integer. The integer we take is the value that we want to reach, so in our case it will be 200. I'll call this value n, and the value that is returned will be the number of ways we can partition this value into coin values. So we're going to do this recursively, so I'm going to define the recursive function that I'll call go, and go will do the following. We take one integer, which is our sum of the sum of coins that we have already taken. Then another integer, which is the value of the last coin that we've taken. That will become important, as you will see. And we return an integer, which is the number of ways that we can reach n. So I'm going to call this parameters csum for current sum and lt for last taken. Now, of course, if the current sum is equal to n, then we've reached our goal. And when that's the case, if we've reached the total value of 200, then we return 1. Now otherwise, we do the following. We need to pick a coin and add it to our current sum of values. And of course, because it's backtracking, we're not going to do this for only one choice of coin. We're doing it for every possible choice of coin. So we are having the coin array here, and we're going to map these, which will just apply the go function again. So if we have a coin value, then we will map it to go. Now the total value increases to the current sum that we already have, plus the value of the coin, and the last coin taken will of course be the coin itself. And after that we just sum it all up, because here we have an array of values that returns well, not an array, a list of values that the values in this list are numbers of possibilities to reach 200 for different choice of coins. And if we sum them up we get a total number. Now, of course, this will not give us the correct answer. First of all, it is possible that, for example, if we take a coin of value 100, a coin of value 50, a coin of value 20, now we're at a total value of 170, and then a coin of value 50 again, then we would be at a value that is equal to 230. In that case, we obviously are on a wrong track, so we need to return 0, because in this current path that we are backtracking, there is no way to reach 200 again. That can be covered with an additional case in this guard statement. So if CSum, if the current sum is larger than n, sorry, just strictly larger than n, then we return 0. Now the other issue is that this doesn't enforce that we don't care about the order in which we take coins. So for example, the partition of the value 200 in a coin of values 50, 100, 50 would be considered, but we would also consider the partition 50, 50, 100, but they're actually the same. So we can solve this by only choosing coins that are equal or greater in value than the last chosen coin. This will enforce an order, and we thereby don't have this ambiguity problem. So in order to do this, we're not going to consider every coin in this array, we're only going to consider the ones that are greater or equal than the last taken coin. That's why we needed to keep track of it. So let's get rid of all the coins that are less than the last taken ones with drop while, and that's it. So now we can write a main function, which is IO. Main is equal to print the number of partitions of 200. So let's go ahead and run this. Well, of course we need to call the go function with the initial values 0 and 0, because in the beginning, when we have no coins taken, we have a sum of 0, and we haven't yet taken a coin, so we can just set a last coin to a very small value. So let's run this with time. And as you see, this gives us the correct answer in about, 0.16 seconds. Thanks for watching.